This is Dr. Sajja Suneel from Data Science Department. Today I am going to discuss you about different IoT physical devices and endpoints. In this particular topic, we already discussed about the introduction, as well as we have seen what kind of IoT devices are there and what kind of IoT endpoints are there. And along with that, we have seen IoT structure diagram, as well as what exactly IoT was. And by using these IoT physical devices and endpoints in different kinds of IoT sectors, we have seen with multiple examples in our past classes. And in today's class, I'm going to tell you about, after the successful completion of discussing about Arduino and Raspberry Pi introduction, today I'm going to show you about how the installations and how the interfaces are going to be useful for our main this IoT physical devices and endpoints. Why interfaces are required? Particularly, these interfaces are required for communication purpose such as serial communication, SPI communication, I2C communication. These are the things which are very crucial and which plays a major role in our particular IoT physical devices and our endpoints. And let's enter into the concept in a quick view. Have a look. As I told you, in this particular module, IoT physical devices and endpoints, today we are going to discuss about the installation and interfaces, various kinds of interfaces which are very helpful for making the communication and for making the data transfer between the IoT physical devices and endpoints. The interfaces are serial communication, SPI communication, I2C communication. These are the three different kinds of interfaces which we are going to talk in today's session as well as in the coming sessions also. Why? Because it was a little bit broad topic, and have a look how the things are. And before discussing about installation as well as these interfaces, I just want to give you a small intro about the IoT devices and endpoints. What exactly an IoT device was, what is an IoT endpoint, and what are the differences between these two, and explaining about different kinds of examples which are used in IoT devices and endpoints. These are the things which I am going to discuss you within a short span. Why? Because we'll have a quick information about what exactly IoT device was, what exactly IoT endpoint was, what exactly the difference between these two, and what are the different kinds of examples which are related to these devices and endpoints. Have a look, guys, what IoT devices are. Physical objects with sensors, actuators, connectivity to collect and transmit the data. We require these IoT devices. And coming to IoT endpoints, these endpoints are required for digital representation of IoT devices in a network when the data is processed and managed. And what was the major difference between these two? A clear picture I am going to show you. IoT device, physical entity, which is a tangible object which is equipped with multiple sensors as well as actuators and connectivity to that particular physical entity. Data generation. Here, I am going to collect the data from the physical world through these sensors. From the physical world means, for suppose, take an example, environment. In environment, which is in physical world, there is a certain temperature, there is certain humidity which is existed in nature. That is going to be calculated through the sensors. And what exactly limited processings are? Here, we are often having a basic processing capability for initial data analysis purpose. And thus examples such as smart thermostats, wearable devices, industrial sensors. These are the things. And coming to the endpoint, a digital representation is required, which is a virtual entry representing an IoT device in a network, as well as which is used for data processing, where the data is going to be collected by IoT device, and also for oftenly doing the analytics part also, we are considering this particular data processing. Through the data which is analyzed, we will get some output. But based on that output, a decision is going to be taken, which is decision making. In this data processing, decision making, complex analysis is plays a major role when we collect the data. That is what data processing is going to do. And coming to the communication, where we are going to interact with different kinds of systems and different kinds of devices, which includes the cloud platforms also, and there are some user interfaces for communication purpose. The examples such as cloud servers, mobile apps, and gateways. These are the examples which are related to endpoints. And in essence, I can damn surely share it that an IoT device is a thing in physical world which interacts with the environment, whereas the endpoint is a digital twin of the device which is responsible for data management and interaction with other systems. Through this, I can conclude with an analogy that think of IoT device as a human body and the endpoint as brain, which process the sensory information for making decisions and controlling the actions. For suppose, take yourself as an example. You will be treated as your human body will be treated as a IoT device and your brain will be treated as a endpoint. This endpoint is the thing which process the sensor information of your human body. In your human body, there are eyes, ears, and there are some things which acts as sensors, right? Through your hands, you are able to sense the things. Through your ears, you are able to hear something. Through your eyes, you are able to see something. With this sensored information, the brain is going to process the data and it is going to take some decisions depends on the data which is analyzed. This is how the IoT basic devices, physical devices, and the endpoints are. And I'll show you a small example for these devices and endpoints. Coming to IoT devices, the first factor which we can consider was smart home, which is in current nowadays, most of the people are using these smart homes with the help of IoT system, which is used. In these smart homes, thermostats, which are temperature sensor, smart lights, door locks, security systems. All these are comes to smart homes. And coming to wearable devices, smartwatches, fitness trackers, which are used. And the next thing, which is examples of IoT devices and endpoints. In these examples, IoT devices, I can say industrial IoT devices, which are temperature sensor, pressure sensor, vibration sensor, motor controllers. All these comes into industrial IoT. And coming to the next factor, which is your endpoints. In these endpoints, cloud platforms, there are different kinds of cloud platforms, which are Amazon Web Services, Microsoft Azure. Currently, in recent industry, you have seen there was a failure in Microsoft Azure. So automatically all the flight system has been jammed due to the Microsoft Azure failure. See how much our cloud platforms are providing service to the industries. And coming to GCP, which is Google Cloud Platform. And coming to mobile applications, whereas smartphones, apps which are used for controlling the IoT devices, wearable device for companion apps, and coming to IoT gateways, where by using these gateways, the bridge is going to be happen and it is going to build the gap between IoT devices and networks. Coming to data analytics platforms, the software which is designed for processing and for analyzing the IoT data. These are the things which are related to IoT endpoint. Now we will discuss about device endpoint relationship examples. The first example was smart thermostat. Smart thermostat was the thing which is related to finding the temperature. In this mobile app or cloud-based control app, it acts as an endpoint. And also wearable fitness trackers. There are n number of wearable fitness trackers which are used in nowadays. Where a smartwatch which is linked to the smart app, where the data is going to be displayed according to the body tracker which is fixed to your current human body. And coming to industrial sensor, the sensor which is the device where cloud-based platforms which is going to be collected and from that data to the endpoint. And coming to the next thing, which is importance of these installations and interfaces. How exactly these are useful. The main role of installation in IoT device lifecycle was we need to find out the efficient communication between the devices which are going to be set up and between the endpoints. There should be a proper communication between the IoT physical devices and between the endpoints. Why? Because based on the human body, which is IoT physical devices, the brain, which is endpoints, these two has to communicate properly. Then only it should take a certain decision. That is what I am narrating you. Coming to the overview of different types of interfaces. What are the different types of interfaces which are going to be very helpful for installation process? I will tell you the process of setting up these IoT devices in intent environment. The first one is interfaces. These interfaces are going to be used for communicating between the IoT devices and the other systems. And what exactly the role of installation in IoT lifecycle was? The exact role was installation will play a major role. Why? Because it is a critical phase in IoT device where it is going to bridge the gap between manufacturing and operational stages. Guys, once again, I am letting you know that it is going to bridge the gap between manufacturing and operational stages. That is what the usage of installation of a particular software was. Here, the things are going to be the theoretical is becoming the practical value, and the device transaction of a product is going to the component into a larger value. Now I will let you know what are the key roles which are existed in installation. First one is physical deployment, which is used for correct placement of device in intended environment. That physical device has to be placed properly. Then only it is able to record the data. Ensuring optimal sensors which are used to place data collection properly, and a proper maintaining or securing the device to prevent damage. If there is no proper maintaining for the camera, automatically the device is going to be get damaged, right? And coming to configuration and setup. After setting up these devices, the parameters has to be set. We need to initialize the device settings. You need to set the parameters. After connecting the device to the appropriate network, such as Wi-Fi, cellular network, whatever the network which you are utilizing, you need to configure the communication protocols based on the data transmission settings. This is how the installation roles are. And some more roles are there, which is integration with systems. With this integration systems, we are going to connect the device to the IoT components and systems. Whereas I am ensuring that there should be a seamless data flow between the device and the backend infrastructure. Why? Because if the data is not going to be transferred to the backend device, what is going to be happen? Automatically, there will be no data for analysis. Automatically, there will be no decision making. For this purpose only, it should be integrated properly with the system. For that purpose, integrating device will play a major role in the existing IoT systems or platforms. And coming to the next factor, which is we are saying as a key role, which is user onboarding, providing necessary instructions and supporting the device operation. Here, we are enabling users to interact with the device effectively, and also we are ensuring the user satisfaction and understanding of device functionalities. These are the key roles which are there in installation purposes. And along with that, security implementation is also an important key role. Why? Because configuring the device security settings, and also we need to implement access controls for authentication purposes, for protecting the devices from unauthorized accesses which are setted. And the next one is testing and validation. Testing and validation will play a major role. Why? Because we need to verify what kind of functionality and what kind of performance was the system is providing. And also, we need to ensure what kind of accurate data has been collected and transmitted. And also, we need to identify the resolving of any installation related issues. These are the things which care plays as a key role. And also, you need to know about importance of effective installation. We need to optimize the device performance. Proper installation is going to be needed, and we need to enhance the data quality by accurate sensor placement, which leads to reliable data. We need to reduce the troubleshooting efforts where a well-installed device minimizes the operational issues. And also, you need to improve user experience for setting up the initiative operation which enhance the user satisfaction. And the next factor, which strengthens the secure position, where the proper configuration and security measure will be given to secure the device from the data. And also there are some efficient communication between the devices and endpoints, which is has to be done in between these endpoints and acts as a backbone which is going to successfully implement the IoT project. And why and how the data will be transferred. There is a real-time data transfer where time-sensitive applications will be there. In this scenario, data is going to be processed and acted accordingly and immediately. Efficient communication, which ensures you the minimum latency and also enables the real-time decision making also. And along with this, predictive management. Here, by using this predictive maintenance, we are going to analyze the sensor data and also the potential equipment failures which are going to be predicted by costly downtime. And coming to the scalability factor, there are n number of networks which are growing in our IoT industry. Why? Because day to day, the infrastructure wise, as the humans are increasing their network very fastly, and in that increasing efficiently, we have a good scalability was there for our IoT projects. For a better efficient communication protocol and architecture is required, and also which is very flexible for the deployment purposes also. Why? Because here we are having an ability to scale up the communication and capabilities up and down whenever you require according to the adaptability changing requirements of the user. For that purpose, the scalability is increased. Coming to the next factor, reliability, where it is having a continuous operation and the operations are very critical environments. Even the downtime is acceptable. Reliable communication ensures an uninterrupted data flow here. And also data integrity. Data integrity plays a major role. Why? Because we are using an efficient protocols and error mechanism techniques to protect the data from corruption due to the transmission process. This is how the reliability is going to be increased. And coming to the next factor, energy efficiency, battery power devices in IoT, by using battery powered devices, whereas we are having limited battery power setup, and which improves the efficiency of communication protocols. And also an extended battery life is also provided with this IoT environment. The security, as I told you previously also, your data is protected and your privacy is protected. How the data is protected? By securing communication channels, we are protecting the sensitive data from unauthorized accesses, and by encryption and authentication we are giving privacy mechanism to you. And coming to the next factor, which is your cost effectiveness. Cost effectiveness also will place a major role, where optimized resource utilization and improved system improvements. Optimized resource utilization, which is efficient communication, which is used for communicating between the hardware requirements, which leads to lower cost. And also the improved system performance, which is faster data transfer, which reduce the latency and enhance the overall system efficiency. Like this, the things are going to be used in installation process. Overview of different types of interfaces which are utilized. Interfaces can be categorized into several types on their function, on their interaction, or the technology involved. Here, the user interfaces are graphical user interface, command line interface. Graphical user interface, which uses visible elements like icons, menus, windows for interaction purposes. Example, you can take a desktop operation system, mobile apps. And coming to command line interface, text-based interaction using commands only, like Linux terminal, command prompt. And also menu-driven interface, which presents option in menu for user selection. ATMs, vending machines, all these things comes under this user interfaces. And the next one is natural language interfaces, whereas voice assistants, chatbots, all these comes under natural language interfaces with the help of NLP guys, which enables interaction through natural language. And touch screen interface, which allows direct interaction with a display using touch, like smartphones, tablets. These can be called as also an interfaces. These are the different types of interfaces. Coming to hardware interfaces, serial interfaces are there. In serial interfaces, we transmit the data sequentially one bit at a time. The best examples, UART, SPI, I2C. We are going to discuss about these serial interfaces in detail in our next class. And coming to parallel interface, which transmits multiple bits simultaneously, example USB and firewire. And coming to network interface, which connects the device to a network such as Ethernet, Wi-Fi, Bluetooth. And coming to sensor interface, which connects your sensors into the system. The examples such as ADCs and DAC, analog to digital converters and digital to analog converters. These are the hardware devices which are existed. Coming to software interfaces, application programming interface, which is API, which is used for software component interact. GUI, graphical user interface toolkit, which provides building blocks for creating GUIs. Command line interface, CLI, which offers functions and also interacts with the command line. Database interface, which allows interfacing with the database. And also there are some other types which are used, which is BCI, brain computer interface. This is going to connect with the brain to a computer, which is BCI. It acts as an interface between the human brain and the computer. And coming to human machine interface, which facilitate an interaction between the humans and machines. This is how the things are. And coming to serial communication, UART. This is the basic concepts of serialization was UART protocol structure, data transfer and flow control. And also we are knowing about the disadvantages and advantages. And also we are seeing some use cases in IoT and how the serial communication was. UART, it is a serial communication. It was a simple asynchronous serialized communication protocol which is used for short range of data transmission. And how this SPI communication was, it was a master slave architecture which is used for clocking data transfer. And what are the advantages and disadvantages which are presented, and what are the different kinds of use cases which I am going to show you. SPI communication, a synchronous serial communication protocol for short distance communication, which is often used for high speed data transfer. The next one is I2C communication. In this I2C communication, which is a multi-master architecture, and also there are some addressings and there are some data transfers. About all these UART, SPI and I2C communications, I will give you a detailed lecture in my next class. And along with that, the advantages and disadvantages over UART and SPI, and there are some use cases which I am going to show you there. And what I2C communication was, which is a multi-master serial communication bus which is connected with low-speed devices. This is how these three communications are, and how the comparison of these interfaces. I will show you a table which is going to tell you about the key characteristics of UART, SPI and I2C, and how to use these things whenever the applications required. And here I'll let you know with these particular things and what the installation considerations which has to be maintained. Device mounting and placement, which is a major part. Power supply options, environmental factors which are temperature, humidity, etc. and also security and privacy functions. These are the four considerations which has to be taken care at the time of installing a proper IoT physical device and endpoints in your IoT system. With this, I will let you know the other considerations also. Once again, the same thing. With this, I can conclude the thing for today's topic, which is installations, and along with that, an intro to your interfaces such as UART, which is serial communication, SPI, and IC2. These are the interfaces which we are going to discuss in detail in the next class. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.